Alrighty. So this is a kind of post solution walkthrough recording. This originally was a couple weeks ago, and I've been thinking about it off and on, and I finally got to working on it and getting to some sort of answer for it today. So this is kind of me summarizing what I did for it. I'll just recreate from scratch, even if it's kind of long and possibly hard, but probably good practice for me. So the problem here is deleting duplicate folder systems. Like if you have folders of a certain path where identical folders are defined to be folders that have subfolders that are empty and have the same names. So for instance, if you have a folder that is AXY, so folder A has folder X, has folder Y, and there is another folder that is BXY, so folder B has folder X, has folder Y, and there's no other folders inside that X folder, so X has folder Y in both cases, then you would mark the AXY and BXY as identical. And similarly, if you have a higher level thing where like A has folder X, which has folder Y, and B has folder X and has folder Y, then those A and B could be marked identical as well, assuming that there's no other folders that go and interfere with that. So for instance, if A has folder Z, but B doesn't have folder Z, then they're not marked identical, but in this case, A has folder X, has folder Y, and A also has folder Z. B has folder X, which has folder Y, and B also has folder Z, so they're marked identical. So the key understanding here, so there's a lot of stuff with this one, but the one key point of understanding that was difficult for me for this problem was how to identify identical folders quickly, I guess, because there could be a lot of subfolders within some folder, and you need to recognize that set of subfolders as being identical. And also, even if you have folders that have a certain labeling to them, if they're not at the same level, like if they could possibly have subfolders that make them non-identical, so like this root folder has A and this folder D has A, but this folder D has A that's empty and this root folder has A that's not empty. That makes this a non-identical. So going through it here, first part of it was to create a system of numbers rather than folder names, because numbers are going to be easier later on. So I'm going to have a string ID map, which is a dictionary, and the paths need to be sorted, because if you sort the paths, the subfolders of a folder is always going to be adjacent. So for instance, A would be next to AB, and if there was an ABC, then that would be following that. So any if a folder has children, it's kind of immediately after it, kind of. Could be multiple children, but within that group after it. So paths.sort, and then for every path in paths, then for every folder in that path, I also want an ID count. An ID count here is going to track unique IDs. This is kind of a, think of this as a global static counter. So I would increment to this whenever I create a new ID. So every path and pass, or every folder in that path, if the folder is not in the string ID map, then the string ID map for this folder is equal to ID count. ID count increments by 1. So this generates a unique ID value for each string. And then I'm going to go ahead and replace the folder. So actually I think this should be for every index in range of the length of the path, the folder is equal to the path of this index. And then the path is now the path of this index is equal to the folder, is equal to the string ID map for this folder. And then I'll just go ahead and do a quick print here. Let's go ahead and create a subfunction, define print path as for every path and paths, print that path. And I'll do a print path before and after. Missing a curly brace or parentheses. Okay, so before it was looking like this: A, B, C, C, B, D, D, A. Technically, these are identical. And now it's replaced with 0, 0, 1, 2, 2, 1, 3, 0. Okay. So that's the first step. And then the second step is to create the tree nodes. So this is going to be something where if I treat each path as kind of a node, almost like each folder is a node, then it'll have children that are its subfolders. And so what I'm going to do here, actually this is not a 2D array, I think it's just a single array. So nodes is going to be equal to this. I'm going to create a class nodes and define the class based on currently it needs to have maybe its index. Okay, I'll pass in all the future arguments that I eventually figured out that I needed. It needs to have a parent connection, an index to which path it is in the path array. So, and it needs to have an ID. The ID is like the 0. It's initially the string ID mapping. And also, at least last but not least, is going to have a set, map to children. This is children ID equals some child node. All right. So to create the, there's one other thing that I eventually would need, and that is when I create the string ID map, I need to have a kind of backwards mapping from the index to the string itself. So this is going to be, let's say folder names is an array, and every time I create a new ID based on a folder that I don't have seen before, I'm going to add that folder to the folder names. Okay. And because this is always in order, like it's going to be the first thing is that 0 index, which is added first. So it's the index matches the folder name. Create the nodes based on paths. Okay, so I need to go through each path. I think maybe this one I definitely need to go through index. Range of length of paths. And I kind of need to create a root node to kind of get things rolling here. So the root node is going to be a new node that is whose parent is none. There's no parent to it. Whose index is also a -1, and its ID is also -1. Kind of dummy values for those. And there's going to be a current node that I'm going to use. So the current node is currently the root node. So if I think about having kind of a dummy root node, it's going to eventually link to this node A, this node C, and this node D, because those are the direct subfolders within the root node. And if I think about how the subfolders and folders compare to each other, each time I go kind of down a depth in the tree, where I go from folder to subfolder, the length of the path of it, how many kind of identifying folder names are in that path, increases. So let's see. So the folder name should be at depth +1. Actually, where the depth is originally 0. So the folder ID is equal to the so for length of paths. So I need to actually create a path variable. Path is equal to paths at this index, and path at depth +1. Actually, I should probably do depth +1 right here. So path at depth +1 is going to be equal to the folder ID. So this would be like 0 at that point. And what I would need is to create a child for that. So the current node dot children is going to add in this folder ID key and map to a new node. Actually, I need to create a new node. Child node is going to equal to a new node based on this current node being the parent. The index is going to be this index, and the ID of it is the folder ID. Yeah. So parent index ID, and for the current node, for its children dictionary, it's going to map the folder ID of it to this child, and then this child node becomes the current becomes the child. Okay, so this is the basic rundown for how the tree would be created if it was just like a bunch of folders with subfolders with subfolders. The issue here is sometimes let's say the folder A has a subfolder AB, which has another subfolder ABC. But then if the next path in this array is actually something that is kind of above, like it goes backwards, then I need to traverse upwards in the thing. So here, there's going to be a while loop. While the length of this path is smaller than depth plus 1, I want to say, then the current traverses to the parent of the current, and the depth decreases. Alright, so let me double check this logic here. So is initially depth is 0. It sees a path that is 1 lane, and the length of the path 1 is not less than, or depth 1 is not less than 0 plus 1. 1 is not less than 1, so it doesn't do this while loop. So it then goes to this depth, which is now 1. Next time it does the loop, the depth is now 1, the path is now 2, the path length is now 2. So it doesn't do this. 2 is not less than 1 plus 1. Now the depth becomes 3. Say depth 0, 1, 2. Yeah, depth becomes 3. And when depth is 3, it's going to say 3 plus 1 is 4. The length of the path is just 1. So it's going to do this, and so 1 is less than 4. So it's going to do this 3 times, 2 times, 4, 3, 2, 3 times. So it's going to go up, 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 goes back to the root, I want to say, and the root depth is 0. 0 plus 1 is 1. Yeah, okay, so I think this is right. And to check that, I'm going to go ahead and print out this node. So for every node in nodes, print out the node.index and node.children. Oh, I didn't actually add the nodes, the child node to, or the current node to the, should be nodes.append current. While list index at a range, path at depth. And 46. So path at depth would be, this should be incremented afterwards. Path equals path at this index. Oh, whoops, this should be up here, I think. While that length is less than depth plus 1. Folder ID is depth, path at depth. Yeah. Guess I should probably maybe put this at the very end. Whoops. Sometimes use child node and sometimes I just use node, I think. Nodes.append the current. Okay. Actually, I'll just do children.keys. Alright, so if I can compare the original paths were like 0, 0, 1, 2, 2, 1, 3, 3, 0. So for this node has a child that has ID 1, so that's the one there. And then for this node, it's the leaf node, no subfolders there, so there's nothing in its children mapping. And then 2 has a subfolder 1, which is that one. 3 has no subfolders. 4 has a subfolder that's 0, and this one has no subfolders, so that's right. Okay, so the next step was to consider that the order of comparison needs to be from the leaf nodes upwards. So in order for you to compare two identical folders, they need to have they need to be okay. So there are subfolders that are leaves that have no subfolders within them. They can't be marked identical, but they're just the starting point. And then the dep1 nodes would be, or in this case, I'll say the leaf nodes are dep0 for this tree, and then the dep1 nodes would be the ones where where we're dealing with a folder that only has leaf folders, so subfolders that are empty, and those are the only ones that can be compared to be marked identical. So I'm going to say this is def nodes as an array here, a 2D array. And to do this, I'm going to traverse recursively downwards in the tree, starting with the root. And the base case will be if you have a node that has no children, then it'll be added to the def nodes 2D array at index 0, whatever that list is. So actually def nodes should actually start with an empty list. So if this node base case leaf node has no children, basically it's a leaf, add to dep0. So if not children or no.children, then dep nodes at 0.append this node, and it'll return the dep that it's currently at. So if it doesn't recurse, then it's dep0, the index that would match to be added to the array list. The reason why this matters is if you have a folder that has both a leaf node and a non-leaf node. So let's say you had something where you have A, AX, AXY, and and AZ. So technically both the Y and Z are leaf nodes. And you can only compare A to another folder that is kind of 2 in length rather than 1 in length as its maximum depth, because that's just how it is, right? Z being kind of dep0, A isn't necessarily dep1 because it can't be compared to other dep1 stuff. It needs to be only compared after figure out if X is somehow related to some other folders. So the evaluation of a folder is based on the maximum depth, the maximum length from it and its farthest leaf is the thing, rather than if it only has leaf nodes, then it's a depth 1, but it has different paths to its leaf nodes, then whichever is the longest path is how long it'll take to be evaluated or compared to other things. So it's going to be, say, the max depth for this node is going to be initially 1 for every child of it. We call the traversal of that child node. So maybe I should call this child ID for every ID. No. For every child ID in node.children, traverse it, and then add 1. I guess it's +1 traverse of that thing, +1. And then that gives you the depth at which this node should be added to the 2D array. So if the length of def nodes doesn't equal max depth, length of def nodes is initially 1, doesn't equal max depth plus 1, I'm going to say. So if it does equal 1, if the length of max, actually I think maybe I should just say equals. So if the length of max nodes is currently 1, and the max depth is 1, so we're dealing with the parents of the children leaves, then you should increase, add an empty list onto that, and then depth nodes at this max depth appends this node and return max depth. Okay, so traversing the children, that's the base case, and then find the max depth of all the children. I think is this parentheses correct? Yeah. If the length of the max, if the depth nodes is 1 is equal to max depth, then add a new list. Okay, I think that's right. So let's go ahead and call on the traverse of the root node. And then I'll just go ahead and print the depth nodes. So for every level in the depth nodes, oh, it's 4. For every, actually let's say print level number, and then for every node in this level, print node.index. Okay. Oops, I think I meant to go by index level. Range of length of def nodes. I could have just done enumerate, I guess. Print out the index. Oh, yeah, okay. index level and enumerate of def nodes. Print the index for every node and level, print the node's index. Okay. Alright, so it should be alright, so here let's go ahead and just print pass first too. Print paths print. So here, the first thing to evaluate, or the first leaves would be A, B, C, B, and DA. So those are index 1, 3, and 5. Okay, and then the ones above that to evaluate would be A, C, and D. So that'd be 0, 2, and 4. And then the root node is at level 2. Something more complicated would be something like this. A has subfolders A, B, which has subfolder ABX, which has subfolder ABXY. So this one would have leaf nodes of ABXY, CB, and WY. So it would be index 0, 1, 2, 3, 3, 5, 7. And then above those would be 6, 4, and 2. And then the next order would be, so you can't compare, so you have to compare AB next. So just 1 and just A is 0. And at that point, yeah, at that point you can actually compare the root node because the root node has A, C, and W. Okay, so I think that's right. And then the next step is to so this is the tricky part, is to evaluate the nodes by depth and do a bunch of mapping of IDs. So there's going to be need to be a, what did I call this? I think I called it like key ID map. It's a dictionary. And okay, so you can start by going through the levels, starting with level 1. So for every level in range 1 to the length of the depth nodes. I think it's the length of the depth nodes. Yeah. And the first thing that I'm going to do is I'm going to do a short, kind of short, this is short circuit. Short circuit if, or actually I think it's break early if less than 2 nodes at that level. So if you have leaf nodes at depth 0 and kind of the parents of the leaf nodes, parents of only leaf nodes at depth 1, those can only be the things that are marked identical, and you should only really care about it if there are more than one thing, because if there's less than one thing, then that just kind of means that you're at the root, or you're at a place where nothing else can be marked identical because there's only one thing to be evaluated. So if the length of the if the length of depth nodes at this level is less than 2, then break. I think I need to have a level key dictionary, and I'm going to go through all the nodes at this level. Actually, yeah, for every node in def nodes at this level. First, I should probably put this above. So here, generate key based on children ID. So for this node, I look at the children ID. So like 0 has 1. So if you have a folder that is like, let's say AX, A has X, A has Z, where X is 1 and Z is 2, then A would have a child, would have 0 or would have 1, 2 as its kind of identifiers of the children folders. So, and if you think about having leaves, let's say the leaf folders are, let's say, well, X, Y, Z. If you have a folder that is AX, AY, you have a folder that's BX, BY, and BZ, and you have another folder that's CX, CY. Then here I'm thinking about generating a tuple for A that is children, that is like maybe XY, and a tuple for B that is XYZ, and a tuple for C that is like XY, and comparing those tuples. If those tuples are identical, then that means those folders are identical at that point. So this is the key that I'm considering. Obviously that's in folder names, but these are actually using numbers because I remapped them to numbers earlier. So generate key based on children. So I'm going to go ahead and say ID. This ID is going to be the list of this node's children, the keys of those. The children is the dictionary, so I'm taking the keys from that dictionary and then taking a list and then you sort the list. Do I need to sort the list? Is it not already sorted? No, I guess the dictionary doesn't sort its keys. This ID dot sort, and then the key here is going to be the tuple generated from this sorted list. And then I'm going to add this key to the map. So if key not in the level key map, so all the keys of this level, actually I'll make this plural. So this means this is a new unique set of folders that I haven't seen before. So this is not identical to some previous folders at this level. I'll say level keys of this key is equal to, I'm going to say this can be ID count and the node ID here, node.index. And else I need to have a marked set. Index of nodes to be that are identical. So if the key is already found elsewhere in this level, then that means there's identical identical folders that can be deleted. So I'll say I just need to know oops, every time I use the ID count, I need to increment the ID count. So it generates a new one, a unique one each time. I just need to know the original previous node that was duplicated here, and I will mark for deletion the previous node's index. Do I want to use node or node.index? So this is previous. I guess it doesn't really matter. I guess I should probably just use node.index. So the previous node that was duplicated, and this node is currently duplicated. So I think that's right. Okay, so that's the level key. The second part of this is to consider how this would apply on the later levels. So this obviously works okay at depth 1. Like, you can treat all the leaf nodes as having unique identifiers based on their children. But if you go to depth 1, or if you go from depth 1 to depth 2, let's say you have something that is if you have a folder that is, let's say, you have a separate example here, dxx, and what am I thinking here? Ex, eyx. So the main concern here is, I guess I'll just try to summarize it, but if you go from depth 1 to depth 2, the folder names in the depth 2 nodes of its children are going to need to differentiate between a leaf node that is of that name versus a node that is that has subfolders with that same name. So like if you have, let's say, folder A Y versus versus B Z. If I have these, if I'm comparing A and B, just because they have the folder names A, subfolder names A within them, the A's there are different because they have different subfolders within them. But if this was AAY versus BAY, these ones would now be the same. So in particular, I'm going to need to rename or re-ID map something that has anything that has subfolders within it. So how did I originally say? Use a replace map ID and replace node ID where unique ID based on node tuple child ID. Okay, so I'm gonna have is this per level or is this outside? I think this is meta, so I think this can be outside here. So replace ID map is a dictionary, and this, so every time I have the key which has an ID next to it, yeah, so I think I called this a new ID is a tuple that is the current key ID. the current level key ID count. So level keys, actually, I think I should just call this child key ID is equal to level keys of this key, the first element of that tuple. And then actually the new key for this node is going to be based on the tuple that is the child key ID and this node node ID. And then if new key is not in the replace ID map, then replace ID map for this new key is going to get a new ID value. And then, okay, so you have your child key, which is like the tuple that is all the children IDs, sorted list of children IDs. Then you map that to a ID based on stuff in this level. So this ID is uniquely identifying, like, let's say XY generates to something that is unique. Let's say it's 100. XYZ generates to something like 101. And XY here generates to something that is 100. So that is this child key ID. And then forming a new key that is a tuple that is that number plus the current node's ID. So say 100 with node A, or with the number for A, or 100 with the number for C. That's going to be used as the next ID. So like if I have 101 or 100 is A, that generates, let's say, 200. And 102, that tuple generates 202. So this is now going to be the new ID for the next level, for the parent level. So the node.parent, so it's going to need to replace itself in its parent's children. So I want to say this should be what? Node.parent children. I think that's supposed to be delete nodes.parent's children of this node ID currently. And then node.parent.children is going to add itself. So the new ID is going to be replace ID map with this new key. New ID for this node is going to be that. It's going to equal this node. And then node ID here is going to equal this new ID. Node.parents.children, delete the current node's ID. Node.parent.children new ID is now connected to this node. Okay, I think that might be right. Did I ever do the marked? I did the marked. So then it looks at the parent, the children of the parent, so of which this current node is one of them. It's going to remove the entry for itself, which currently is based on its current ID. It's going to add a new entry for itself with the new ID that it has. So basically, if like A is in a subfolder, say M, it's going to replace A, which is like 0 within the children M with like 200. And let's say there's another folder N, and that folder has C in within it, then it's going to replace the C with 202. So it keeps on kind of creating new ID mappings for each folder at each level. Okay, I think that might be right. Okay, so once that is all done, then the marked set is marked, and I just need to create the array of the answer. So let's say I have an answer array, answer 2D array, for every index in range of the length of paths. If the index not in the marked set and the parent of the node of this index is not in the marked set as well. So parent of this node at this index. So nodes index dot parent index not in marked. Actually, so I'll just say if it is in marked or the parent is in marked, then can continue. Otherwise, answer.append paths of this index. And then finally, I need to remap the paths to its original file names. So for every path in, actually, do I need to do this? Yeah, for every path in paths, for every index in range of the length of this path at that index is equal to, I think this is folder names, converting the ID, so the ID there is currently path at this index. And then return the path, return the answer. Array path and answer, actually. Or the index in range of the length of this path. Path at the index equals folder names. Okay. Wow. It's amazing that that worked without errors in that run. So I think I just need to remove the prints at this point. There's still some printing. Output is, no, that's not printouts. Okay, that's actually yeah, so it works. It doesn't work terrifically, but it works. I've never really tried kind of cycling through IDs like this, like wrapping a tuple into an ID and then using another tuple with that same ID in another tuple. But it's definitely testing my limits of complexity I can imagine. I wonder if I can go to store Leetcode. Where is a ticket? Do, 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 do. Huh. Does it automatically ask me to use this ticket? Thought it would. Oh yeah. Still streak 3 because there was another thing I didn't solve between now and then, but oof.